Okay. Here's the homework for the section 322 review preview. Problem number 78 says simplify the expression below. So in order to do that, for A, the first thing that I had to do was factor it. So I factored the top into x minus 4 times x minus 4, and the bottom factored into 3x plus 2 and x minus 4. So then I knew I could cancel out the two x minus 4s. So my final answer was x minus 4 over 3x plus 2. For B, the top I factored out a 5. So I ended up with 2x plus 5. And then in the bottom, I factored it to 2x plus 5 and x minus 3. So the 2x plus 5s both canceled. So my answer was 5 over x minus 3. For C, I was dividing. So I had to factor it, but I also had to remember to flip the second one. So actually, I didn't have to factor it. It was factored for me already. So k minus 4, 2k plus 1, over 5, 2k plus 1, then times 10 groups of k minus 3 over k minus 3, k minus 4. So then I could cancel out lots of different things. The 2k plus 1 cancels, x minus 4s cancel, the k's minus 3s cancel, and then 5 actually goes into 10 twice. So my final answer was just 2. Problem number 79, how many solutions does each equation below have? So I can solve them to C. So for A, I subtracted 3x from both sides and got x plus 3 equals 3. X equals 0. So this one has one solution. For B, I'm going to distribute. I get 3x minus 12 minus x equals 5 plus 2x. When I simplify this side, I get 2x minus 12. Subtract 2x from both sides. I'm going to get negative 12 equals 5, which is not true. So the answer is no solution. Or none, because it said how many solutions does it have. For C, I can use the zero product property and know that 2/5 and negative 4 solutions. So it has 2. And for D, if I factor it, I get x minus 2, x minus 2. So I know that 2 is the only answer, so it has one solution. Problem number 30, David wants to solve the equation 4,000x minus 8,000 equals 16,000. What easier equation? I could divide everything by 4,000, which would give me x minus 2 equals 4. So it says justify that your equations are true. So I would solve both of them. So 4,000x minus 8,000. So I'd add 8,000 to both sides. So I get 4,000x equals 24,000. Divide by 4,000. I guess x equals 6 would be if I left it exactly the same. If I used my easier equation, I just add 2 to both sides. I still get x equals 6. So in D, or C, sorry, it says use his equation, write and solve an equivalent with easier numbers. I can multiply everything by 100. So when I do that, it's going to cancel out my denominators. So I just get x plus 3 equals 8. Subtract 3 from both sides. I get x equals 5. Problem 81, I am solving some inequalities. So when you do this, the first thing that you do is just solve as if it was an equal sign. So like I would do 5 plus 3x equals 5. So I subtract 5 from both sides. I get 3x equals 0. Divide by 3. So x equals 0. But in this case, it's less than 0. Since I didn't divide by a negative, my sign stays the same. So if 0 was here, I would put an open circle at 0 and a line going to the left. For the next one, first thing I'm going to do is, again, I'm going to let it pretend that it's an equal sign. So I'm going to add x to both sides. So I get negative 2x equals 8 divided by negative 2. So x, negative 4. Since I divided by a negative number, it flips the inequality. So my answer is x is less than or equal to negative 4. So now I'm going to use a closed circle, and it's still going to go towards the left. Problem 82, it says we're going to focus on multiplying and dividing. So we want to do these problems without a calculator, and then you could use your calculator to check it. So like I did 2/3 times 9 over 14. I actually reduced it first. You could have multiplied straight across and reduced after, but I know 2 goes into 14 7 times, and I know 3 goes into 9 3 times. So then I just got 3/7 as my answer. For the division problem, make sure to keep change flip. So 3/5 times 25 over 12. So again, I'm going to reduce first. 3 goes into 12 4 times. 5 goes into 25 5 times. So I get 5/4 or 1 1/4. Problem 83, it said sketch the graph of y equals x plus 2 cubed plus 4. So when I did this, I know that my switch is going to be at negative 2, positive 4. So negative 2, 1, 2, 3, 4 right here. So when I sketch it, it's going to end up looking like that. And then it says, what's the parent function and how has the graph been transformed? So my parent function is x cubed, and it was moved left 2 and up 4. It says rewrite the equation without parentheses. So the first thing I did was you have to do x plus 2, x plus 2, x plus 2, and then plus 4. So when you multiply that all out, you end up with, let's see, x cubed, and then add the 4 plus 6x squared plus 12x plus 12. And then it said, how would the graph in part B differ from the graph in the original equation? It wouldn't. They would be the same graph. Okay, problem 384, sketch the graph of the function. So the graph of the function should have looked like this. It's exponential. So what's the domain? So the domain is all reals. Sketch the graph of the geometric sequence. So I didn't quite make my graph big enough, but it would just be a series of dots. So like I had a dot right here, and then there'd be a dot like I'm up there. What's the difference? Well, one is linear because it's 15n. The other one is continuous while one is discrete. So f of x equals 3 times 5 to the x is continuous. And t of n equals 3 times 5n is discrete.